Have you ever wondered why the price of a plane ticket can jump around so much, or how two people with the exact same job can have totally different salaries? Well, that's what we're talking about today. It's all about the spread in data, and why understanding it is absolutely key to making sense of the world.
So let's dive right in with a real-world puzzle. Imagine you're shopping for a used car. Same make, same model, same year, but the prices are all over the map. Why is that? This simple question, it gets right to the heart of what we call variability, why data points can be so different even when they look pretty similar on the surface. To make this super clear, let's meet Marcia. She's got a growing greeting card business, and she needs a dependable car for deliveries. She's decided on a 2005 Chevy Cavalier, but she's running into this exact problem. The prices she's seeing go from $800 all the way up to $1,500. So, how does she know what's a fair price, what's a good deal versus a ripoff? Let's help her figure it out.
Now, our first thought might be to just find the average price, right? But that really doesn't give us the full picture. To really help Marcia, we need to go a step beyond the average and understand the spread of the data, which is just a fancy way of saying its variability.
Okay, so variability might sound a little technical, but I promise the idea is really simple. It's just a way to measure how spread out or how clustered together a bunch of numbers are. Are all of Marcia's car prices clumped together around one number, or are they scattered all over the place? That's what variability tells us.
The easiest way to get a feel for this spread is to look at the range. You just take the highest value, in this case $1,500, and subtract the lowest, $800. So for Marcia, that's a $700 range. It's a quick and easy snapshot, but the range has one big flaw. A single really high or really low price can totally throw it off and give you a misleading picture of what's actually going on.
So yeah, the range is a good place to start, but we need a more powerful, more reliable tool to get the real story. And that brings us to the most valuable player of variability, the standard deviation.
All right, let's roll up our sleeves and get into it. We're going to walk through exactly how to calculate this thing. And trust me, it's way more straightforward than it might look. Once you get this, you'll unlock a much deeper way of looking at pretty much any data you ever come across.
So what is it really? Well, in simple terms, the standard deviation tells you, on average, how far each data point is from the center of all the data, from the mean. So if you have a small standard deviation, it means all your data points are huddled together. A big one means they're really spread out.
Okay, now you're going to see a formula on your screen, and yeah, it can look a little intense with all those symbols. But please, don't worry about memorizing it. Just think of it like a recipe. It's just a series of simple, logical steps, and we're going to go through them one by one right now.
Here's the 5-step recipe. First, you find the average of all your numbers, that's the mean. Second, for each number, you figure out how far away it is from that average. Third, and this is a really clever trick, you square all those differences so you don't have to deal with negative numbers. Fourth, you find the average of all those new squared numbers, and that gives you something called the variance. And finally, step 5, you just take the square root of that variance and boom, that's your standard deviation. That's the whole process.
Okay, let's make this real. To keep the math from getting crazy, we're just going to use a different set of numbers for a second. A list of 10 test scores. So, step 1, find the mean. We add up all the scores, divide by 10, and we get a mean of 60. You can see we've put that in the second column next to every score.
Now for steps 2 and 3. We take each score and subtract the mean, 60. So for that first score, 57 minus 60 is -3. Then we square it. -3 times -3 is a positive 9. We just do that for every single score down the list. And squaring is so important here because it gets rid of all the negative signs. We don't care if a score is above or below average, just how far away it is.
So once we've filled out that whole last column with all of our squared differences, we do step 4, find their average. Just add up that whole column, divide by 10, and we get 25.6. This number has its own special name. It's called the variance. We are so close now.
And for the final step, all we have to do is take the square root of the variance. The square root of 25.6 is about 5.06. And there you have it. That is the standard deviation for our test scores. This one little number neatly summarizes how spread out all those scores really are.
So, great. We have this number, 5.06. But what does that really mean? What does it tell us? To understand the real power of this number, we need to see it in action. And the best way to do that is with something called the normal distribution. So it turns out a whole lot of things in the real world, from test scores to how tall people are, to yes, even the condition of used cars, they all tend to follow this really predictable pattern. Most of the data clumps right around the average, and then it gets less and less common the further you move away from the middle. And when you graph it, you get this beautiful, symmetrical, bell-shaped curve. And this is where standard deviation becomes so incredibly cool. For any data that follows this bell curve, there's a simple rule. About 68% of all your data will be within one standard deviation of the average. About 95% of it will be within two standard deviations, and almost all of it, 99.7%, is going to be within three. This is a massively powerful rule for understanding your data at a glance.
So what if we want to know where one specific car price or one specific test score fits into this big picture? Well, we can calculate its z-score. A z-score is just a simple number that tells you how many standard deviations a value is from the average. If it's positive, it's above average. If it's negative, it's below average. It's basically like a universal measuring stick for your data.
All right, we have our tools, we understand variability, we know how to calculate standard deviation, and we get the whole bell curve thing. So now, let's put it all together and go back to our original problem, helping Marcia pick out the right car.
Remember how we said that the cheapest cars were in rough shape and the most expensive ones were pristine? Well, that fits perfectly with our bell curve. Those $800 cars, they're the outliers, way out on the low end. They're cheap, but they're probably going to be unreliable. And those $1,500 cars, they're the rare gems on the high end. Perfect, but really hard to find.
So, the smart move for Marcia isn't to chase those extremes. Her best bet is to look right in the middle, in that big chunky part of the bell curve. That's where about 68% of the cars are, the ones in good to very good condition, probably priced somewhere around the average of $1,300. That's the sweet spot where she'll find the best balance of quality, price, and options.
So let's just quickly recap what we've learned. Variability is the story of how spread out your data is. Standard deviation gives you a single, powerful number to tell that story. The normal distribution, that bell curve, is the map that helps us see what's normal versus what's an outlier. And when you put all these tools together, you can make way smarter, data-driven decisions about pretty much anything.
I just want to leave you with this one last thought. The average, or the mean, is super important. It gives you a center point, an anchor. But it's the standard deviation that really tells the story. It gives the data its personality. It tells you not just where the center of the crowd is, but exactly how far you or your data point has wandered away from it.